Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important topic, that is from electromagnetic theory under the electrostatistics. So, up to now we discussed about core syllabus of CSIR electromagnetic theory. In the core syllabus of CSIR electromagnetic theory, the first topic is electrostatistics. In electrostatics, we discussed about the Coulomb's law and application of the Coulomb's law. I uploaded on our YouTube channel. And Gauss law and Gauss law applications are there according to your syllabus. They are quoting. So, according to your syllabus, I discussed the old previous questions, Gauss law and applications of the Gauss law also I discussed in the last YouTube channel classes. Now, according to your syllabus, after finishing the Gauss law and applications of the Gauss law, we are discussing in the applications of the Gauss law, we are finding the electric potential also. That electric potential also we are discussing in our previous classes. Now, the subsequent topic is the Poisson's equation and the Laplace equation. So, yesterday and the day before yesterday, we discussed about the Laplace equation and Poisson equation. So, we discussed the Poisson equation one question and the Laplace equation one question we discussed. Today, we are discussing about the electrostatic energy. This electrostatic energy directly they are not quoted in the syllabus. That boundary value condition also we discussed in the last previous video. Under the electrostatic boundary condition, various boundary conditions you may get it. So, in electrostatistics you may get the boundary condition, in magnetostatics you may get the boundary conditions, and in the dielectrics you may get the boundary conditions, in electric dynamics you may get the boundary conditions, various boundary conditions you may get. So, according to the electrostatic boundary conditions, I told one question to you. So, today we are discussing, in this video we are discussing about the electrostatic energy. This question was asked in CSIR June 2017. So, CSIR June 2017 they are asking this question. First you have to read the question, you understand the question, then it is easy to apply the orientation once you have to see. So, two long hollow coaxial conducting cylinders. Here two long hollow means there is a shell. So, hollow conducting cylinders of radii R1 and R2. R1 is less than R2. So, R1 is less than R2. So, R1 is less than R2. Suppose you have to take maybe you have to consider this is the center of the origin. You have to take this is a R1 radius is there. So, what is that radius? R1. So, the outer one you have to take it as a R2 radius. R1 is less than R2 they are giving. Are placed in vacuum as shown in the figure below. The inner cylinder carries a charge plus q plus lambda. The inner cylinder carries a charge plus lambda per unit length. This is a charge per unit length, linear charge density. The outer one, so the outer one minus lambda, the outer cylinder carries the charge minus lambda per unit length. What they are asking once you have to see, the electrostatic, they are asking about the electrostatic energy. The electrostatic energy per unit length they are asking. The electrostatic energy per unit length means W by L is equal to how much they are asking. This is the question. First you read the question 2-3 times. You understand the what data they are giving in that question. First you understand. The 50% of the solution is completed. The latter, so you think about what formula I have to use, whether I may know the formulas or not, you have to see. First you read the question thoroughly. Two long hollow coaxial conducting cylinders, two long hollow coaxial conducting cylinders of radius R1 and R2 are placed in vacuum as shown in the figure below. The inner cylinder carries a charge plus lambda per unit length, that is the linear charge density plus lambda. The outer cylinder carries a charge minus lambda per unit length, we need to calculate the electrostatic energy per unit length of the system. We have to calculate. How we have to calculate? Once we have to see, this is a very interesting question. First we need to solve the question, means we have to come to know the previous knowledge under the electrostatistics to find the electric field. First you able to see, this is a cylinder, inner cylinder of radius A. So there is a outer cylinder of radius, this inner cylinder of radius R1, that outer cylinder of radius R2 is there. So this inner cylinder, outer cylinder, you may take, so this radius is equal to R1, this radius is equal to R2, this inner cylinder is the linear charge density is plus the outer cylinder, that linear charge density is equal to minus lambda. Now this is the your expression. So based on this we have to calculate. We know that when R is less than R1, when R is less than R1 means inside the inner cylinder your electric field E1 is equal to 0. Your electric field E1 is equal to 0 because it is a cylindrical shell, right? Now you able to take, that is a hollow cylinder. So these are the hollow cylinders. Which cylinders it is? Hollow means there is a shell, nothing is there, hollow cylinder. So hollow cylinder, there is nothing is there, so that's why we have to take it as a E1 is equal to 0. When R1 is less than R is less than R2, when R1 is less than R is less than R2, your electric field E2 is equal to, it can act as a infinite charge, infinitely charged wire like that it can act. So that's why what is that, lambda by 2 pi epsilon naught into R, your E2 is equal to. So this charge can act as a infinitely long charged wire like that it can be act. So therefore lambda by 2 pi epsilon naught into R, you have to get it. So now the 3 is equal to, when R is greater than R2, so your electric field is equal to E3 is equal to 0. When R is greater than R2, your electric field is equal to 0. But you know one thing, what is the, so energy, electrostatic energy, the electrostatic energy we need to calculate. Electrostatic energy, how we have to calculate the electrostatic energy? That is W is equal to, there is a formula, epsilon naught by 2 into integral all space, epsilon naught by 2 into integral all space into dV and E square into dV. So therefore you substituted here according to this electric field, you have to substitute W is equal to epsilon naught by 2 into integral R1 to R2, E square is equal to lambda square is divided by 2 pi epsilon naught into R square. So 2 pi epsilon naught whole square into R square. So dV, this is the volume element under the cylindrical coordinate system, 2 pi L into R dr. So this is the volume element under the cylindrical coordinate system. So what are the things are there outside? You have to take outside. So W is equal to epsilon naught is divided by 2 into, you have to take 2 phi L is divided by 2 phi epsilon naught whole square. So you have to take 1 R get cancelled, integral R1 to R2 1 by R into dr, integral R1 to R2 1 by R into dr, 2 phi epsilon naught 1 2 phi epsilon naught get cancelled. So therefore which one we have to get? It is a lambda square is there, that lambda square also you have to bring outside. So now you able to get, so W is equal to lambda square L is divided by 2 into, so 2 phi epsilon naught, rest of the thing I am writing, integral R1 to R2 1 by R into dr. So integral you able to take it is a lambda square divided and L into 4 phi epsilon naught into, so you have to integrate 1 by dr by R is equal to ln r, you have to apply the lower limit and upper limit you have to apply. Lambda square L is divided by 4 pi epsilon naught into ln r2 is divided by r1. So log a minus log b is equal to log a by b, which is equal to w. So therefore electrostatic energy per unit length, this is the electrostatic energy. Which one it is? This energy we call it as a electrostatic energy. Electrostatic energy, this energy we call it as a electrostatic energy, but they are asking electrostatic energy per unit length. So therefore electrostatic energy per unit length, electrostatic energy, therefore the electrostatic energy per unit length is equal to, per unit length, electrostatic energy per unit length is equal to how much unit length? You able to see, that is W by L is equal to lambda square is divided by 4 pi epsilon naught into 4 pi epsilon naught into ln r2 is divided by r1. So this is your answer. So write once you have to check, this is the energy, electrostatic energy per unit length is equal to lambda square by 4 pi epsilon naught into ln r2 is divided by r1. Once you have to check the answers, so from these answers lambda square by 5 epsilon naught is correct, lambda square by 4 pi epsilon naught correct, but r2 square by r1 square is not correct. So lambda square by 4 pi epsilon naught into ln r2 by r1, this is the correct option, you may get it. So therefore D is equal to lambda square by 2 pi epsilon naught is not correct. Which one is correct? Option C is correct. Like this we have to solve in our competitive exam. Very simple if you know that things. So once again I am informing to you. So we started Quantum Online Academy app. So in that app we are giving the coaching of CSIR and GATE physics content, JL physics content and DL physics content we are giving into you. So you download our app, that is Quantum Online Academy app, from your Android mobile phone. You have to download that app, that is the Quantum Online Academy app is there. My mobile number is 9908437460. This is my mobile number. In that app courses will be displayed like this: CSIR and GATE physics course, and JL physics content and DL physics content is available like this. The mathematical methods of physics, this completed, this paper is completed. Individual paper also is available. Mathematical methods of physics, this paper, whole paper is completed. Like this course is there, you able to take this one. Classical mechanics is there, this paper also completed, right? If you want to take only classical mechanics, you have to take this one. Now so the electromagnetic theory is going on, that's why I am teaching in the YouTube also electromagnetic theory simultaneously. The live plus recorded classes are available on electromagnetic theory, live plus recorded classes, morning 6 a.m. to in between 8 a.m. So morning 6 a.m. in between 8 a.m. there is a live class is going on, that is electromagnetic theory. All these days in the evening also, in between 7 a.m. to 8:30, 7 p.m. to 8:30 p.m. in between 7 p.m. to 8:30 p.m. So there is a live class. 2 times I am taking to finish the syllabus as much as possible. So maybe in the month of April and May, so these 2 months I have to finish the electromagnetic theory, entire the portion I have to finish to you. So please share and subscribe and like our YouTube channel. So like these videos we will upload in our YouTube channel, learn the physics subject. So not only learn the physics subject, you have to inform to your friends also who are in the physics fraternity. So those people will listen from their hometown only, because it is purely online mode. Thank you so much.